we're going to go ahead and get started. Just go ahead. I want to, one more time, just a reminder, please put your microphones on mute, okay? All right. Today we're going to talk about our electric fryers. Now, when we talk about electric fryers, on this one right here, we're going to pretty much talk about the basic one, which, you know, has the manual filtering on it. All of this holds true, whether it's a Love Fryer, a Filter Quick. Those are the ones that you press a button and they filter by themselves. They prompt you to filter. Even if you have a touchscreen fryer, all of the stuff that we're going to talk about today, okay, also applies to that. The heating features that we have on our the touchscreen fryers are more advanced fryers. The heating part of it's the same. We took that fryer and just added sophisticated filtering system, and then with the touchscreen, again, go ahead and put your microphones on mute. Somebody's not on mute, and there's a lot of interference. All right, but yeah, even with the touchscreen, I mean, the heating portion of it's the same. Okay, some of the controls and stuff is a little bit different. The controller actually has different functions than the ones we have now. Yeah, again, somebody's not on mute. If you could go ahead and put it on mute. All right, but this right here is a Love Fryer, but we'll talk about different fryers as we go through here. But like I said, basically they're all the same as far as the heating portion goes. All right, on these fryers here, whenever we're accessing certain components, all right, for troubleshooting, a lot of what we're going to need to get to is going to be behind this controller right here. We have a bezel that's held. We have screws that go underneath here. There's on this case here, there'd be 3 Phillip head screws. Once this bezel comes off, these controllers then have a 1/4-inch self-tapping screw on each corner here, okay, that holds it up. When you take those out, you drop the controller down or just hinge it down like you would a, you know, oven door, tailgate of a truck. This is what you're going to see, okay? Not a lot back there. A lot of the things that we have with electric fryers have to be sealed in boxes, okay, that's a UL requirement. So we have a lot of the stuff that is sealed up in the contactor box, and we'll get to that later, and I'll have to do some apologizing there. It's not the easiest thing to get to. But behind the controller, we have the interface board, we have a 12-volt and a 24-volt transformer. Basically, that's it. But as far as troubleshooting goes, the amount of troubleshooting we can do on this interface board is quite a bit, because these plugs right here, it used to be test points. Some of you guys that worked on fryers that were older than May of 2006, okay, these here were test points and these plugs were on the back. All right, when we redesigned this and came up with the RE fryer, which is the rotating elements, that's what these cylinders here are for. Whenever we redesigned it, we went ahead and put the plugs on the front just to make it easier to access. Okay, so we have, well, and we'll get to that here in a second, how they're labeled. But this right here would be a full pot fryer because we only have one side. We don't have the latch and the heat contact or relay for this side here. And so this would be a full pot fryer, which we'll get into that a little bit later. All right, but this is what you're going to find behind the controller. All right, the design change that we made in May of 2006 was we put a cylinder here that has seals on both sides. All right, and this was to reduce the oil migration. Prior to this, it's hard to believe it's been 14 years ago, but prior to this, the elements was on a plate. And whenever the elements would lift up, all right, that plate would open and actually be basically a trap door. And we had some issues with oil migration. If people were cleaning the fryers with the elements up, you know, and they're ladling oil down here to wash the sides down, which is a pretty effective way to clean the fryers, but the oil would get in the back, and we had some real concerns there. So in 2006, they had a design change where they had this cylinder. All right, I gave you my email address, and for those of you that haven't written it down, there it is. If ever you're working on one of these fryers, and I mention this in all the classes I do when I travel around the country doing these classes, if you find one that has an issue where we have a lot of oil built up, now let's keep in mind this is a fryer, we're going to have some. I mean, there's no way around that. But if you have a lot of oil back there, go ahead and get some pictures of this. We've had them out there for 14 years, and I think we've absolutely proven that this has pretty much eliminated the oil migration. And again, there may be a little bit. You're going to have vapors and stuff that's going to get in everything. All right, but we just need to see if there's an issue where we have a lot of oil migration. We need to know about it. And to this point, we haven't. I mean, I think this pretty much solved the problem we had with oil getting in the back of the fryer. All right. This does open up a few questions. Whenever these elements are mounted on here, this tube is not thick enough to thread. Okay, so we couldn't put, bolts in here, to weld a nut in the back. If we was to do that, there would be absolutely no play whatsoever, okay, on here. So if these things didn't perfectly line up, which they should, they're all made the same. But again, we're all technicians. We work on stuff, in the real world, sometimes that stuff doesn't line up. It's nice to have a little give, and a nut and a bolt, or a screw in this case here, okay, makes it a little more forgiving to line that stuff up. This here shows a flathead screw. They're no longer a flathead screw. The only reason we use that, and believe me, I realize when these things get built up with oil, how hard it is to get that hardware off there, especially with a flathead screw, because it's not the best fastener in the world. But the thing of it is we had to have that because of NSF requirements. So, but now we actually have a regular bolt head on there, and then we have a nut that goes on the inside. So the length between here and here, okay, there is a nut on either side of this. All right, we do have a wrench. I mean, I don't know who has changed this. If you've never changed an element before and you're thinking, oh boy, that's going to be an impossible job, don't think that way, because it's not that hard. I've changed quite a few of these elements because we had a customer one time that wanted to switch from 17 kW fryers to 14 kW, so we did a lot of element changes. It is not that hard, okay? The hardest part about changing the element is getting this tilt housing cover back on, okay? And that's just getting everything lined up. It's one of those jobs that a third hand would be real handy, but it's just getting all this stuff lined up. It's not impossible. It's just if you have somebody to give you a hand, somebody in the store or whatever to help balance it, it helps out. Not tough, it's just a little cumbersome. All right, but other than that, changing the elements, not a hard job at all. The one suggestion I do have, put something on top of the fry pot cover if it's available. Hopefully it is. I mean, all the fryers come with them, but if you can get that, put that on there for a couple of reasons. One, if you're like me and drop hardware a lot, okay, it'll keep it from going down into the pot. All right. The other thing is to rest the element on there to take all the weight off, of having to hold them. That way, when you turn this, and you can turn this cylinder right here to where it'll completely line up, and the springs, if they're still intact, okay, will hold in that position. Once you line it up, it makes it a lot easier. If you're trying to balance this and line these screws and stuff up, and you have the whole weight of the element, it makes it a little bit harder. But other than that, changing these elements are not that hard at all. The other thing about these, and you can't see the probe on there, this must have been a prototype or something, but we have the temperature probe that goes on the elements, and I'll talk about why we have that on there a little bit later. But we have the temperature probe that goes on the element, okay? That probe feeds through here, okay? Changing the probe is not hard at all. One thing I will tell you, if you have to go out and you know that you're changing a probe, do not take this tilt housing cover off. It does not have to come off to change a probe. If you take the second panel in the back of the fryer off, okay, that'll give you all the access you need. The wires plug into the back of the fryer down below in a plug, all right? And then you can, however you want to do this, you can cut the wires, pull the probe out the front, okay? Those wires from the factory are in this insulation here. When you change a probe, they do not have to go back in the insulation. We have to have the insulation because of the wires from the element, but it's not a requirement that we have those probe wires in that insulation. We do it here in the factory because it's not that hard when we're building it from scratch. But whenever you're changing a probe, there's wire ties that come with it. Just go ahead and tie it to the outside of this here. All right. Changing this probe does not take long at all. But again, do not take off that tilt housing cover because it's not necessary. You can pull that probe out the front and then just feed the new one in, and then the wires will just go down the side. All right. One of the things when we get to the contactors and stuff, I mean, changing contactors on these is very tough, but it depends on the configuration of the fryer. I think I've changed probes on these fryers in pretty much every configuration, and I don't know of any time when you would ever have to take off that tilt housing cover. Okay, that's the part with the basket hangers on. I can't think of any, and I've changed quite a few of these probes, I mean, over the years, but, it's been 14 years. But, yeah, don't take that off. That would be the hardest part. It takes about 20 minutes once you get access to the fryer to change a probe, if that. All right, it's not a tough job at all. And keep in mind, you do not have to run those wires down through there. Once this gets oil on it and it gets hard, that would be an almost impossible job. So we've never expected anybody to do that. All right. If you're changing an element, we do have a wrench. It's a little bit hard to see, but if you follow along, this goes down here, comes to a right angle, and then comes up, and then you have that little handle there. The distance between here and here is the distance between here and those screws. So this right here is a cradle that you can put the nut in and then pull that over, and then it should line up. In training, I use these to show how they work. I don't use one whenever when I was changing elements most of the time, I already had tools and we didn't have this available at the time. A lot of people say they're very handy. There's a million different ways to get to that nut. It's not that hard of a job. We've all changed hardware before. I mean, we got wrench, you can have a wrench, and have a nut, put a piece of tape on it, whatever. But anyway, if you feel that this is going to be handy, you work on these fryers a lot, here's the part number. You can order them. I don't know what the cost is. I don't keep up with that anymore. We don't sell parts from here. But that's the part number for this wrench here. All right. And again, that's just a cradle that'll hold that nut in place. And the distance here is the distance there. All right. But anyway, all right, here's the contactor box. Okay, this one here is not that bad because one, we don't have the jug of oil here that we have on the newer style fryers. Depending on the configuration, some of these boxes are extremely tough to get to. Okay, I can't say that it's not, but it is what it is. Whenever we send these out, to get all the approvals that we need, it's got to go through UL and NSF and all the other ones. Even if we have a fryer that, and we try to make them serviceable, obviously, because, we got to work on them too. Not only that, whenever we got to have somebody go out there and work on them under warranty, the harder it is to work on, the longer it takes to work on. So it's in our best interest too to make them easier to work on. All right. Unfortunately, this contactor box has always been an Achilles heel, is trying to figure out where to put it and be able to pass all the agency requirements that we have. Using this same platform of a fryer and adding all the stuff that we had to for the low oil volume fryers, or the 30-pound fryers, the automatic filtering ones, made it even more of a challenge. Because this one here, being the left-hand fryer, you would have a jug right here, a 5-gallon jug of oil. Okay, not to mention all the other boards and everything that goes with that fryer. So again, we have videos on changing contactors. I was the one changing the contactor in the video. I tried to get a fryer that was one of the harder ones to access these, to do that, but there is so many different configurations of fryers. It just depends. Some of them not that hard to get to. Other ones are tough. All right, but anyway, the newer fryers that we have coming out, the touchscreen fryers, we have access panels, on the side panels come off, so it does make it easier. The new design fryer that we're working on now, and obviously, all this virus stuff has set all that back a little bit because we don't have people actively working on it now. But the ones that we're coming out with now, contactors was one of the top things on the list to make it easier to get to. Okay, contactors, I mean, even though we got a contactor now that holds up really well, contactors are a wear item. Those things are cycling on and off over and over hundreds of times a day. Sooner or later, they're going to go bad. It's a wear item. All right, so we need to make those easier to get to, or we're trying to make those easier to get to, because it is something that you're going to eventually have to access. All right, the contactors that we have, prior to April of 2008, we used to use Mercury contactors for our heat contactors. All right, there's nobody here that's going to tell you that the mechanical contactors are better. Unfortunately, Mercury has become something that is a substance that, some countries, as long as I've been here, 20 years, we weren't allowed to put Mercury in certain countries. All right, then it got to the point where some of our major customers, they did not want Mercury in their fryers. All right, just to have it in the store. So in 2008, the decision was made in partnership with a lot of our bigger customers that we were going to go away from Mercury contactors. The original ones that we used was very similar to this. Okay, just 10 amps bigger. These are 40 amp contactors. We were using 50 amp. Um, and they held up as long as they said they were going to hold up, which was about the 3-year range. But, you know, with the lifespan that a Mercury contactor had, once those mechanical contactors started going out, it was decided that's not long enough. So we had to look for different contactors. This is the contactor we went with. It's a Schneider, okay, is the brand name. But anyway, we'll talk about that a little bit more later in a little bit more detail. We went with these June 2017, and they seem to be holding up really well, okay, much better than the other ones did. But in this case here, this would be a contactor box for a split pot fryer because we have two latch contactors and we have two heat contactors. These are used as heat contactors because they cycle on and off over and over. A latch contactor is going to pull in once a day and that's it. All right, unless you shut it off again, you know, for whatever reason. But normally, in normal operation, you come in, you turn the fryer on, you hear that clunk. That's the latch contactor. It pulls in. That's it. Okay. The heat contactors are the ones that cycle on and off over and over. All right, interface board, we'll go a little more detail on this. We have these plugs now on the front where this used to be test points. When we get to the wiring diagrams and also here, we're going to talk about what we can check using those test points. To access this, again, the only thing you're going to need is a 6-in-1 screwdriver. You need a Phillips head screwdriver to take off the bezel. And then on the controller itself, it's got 2 1/4-inch self-tapping screws that you're going to need to take off. Once you hinge that controller down, okay, then you're going to see this interface board with the transformers, that slide I showed you earlier. This interface board was the one that we came up with back in 2006. May of 2006 is when the RE fryer was released, and that's when we had the plugs on the front. The only thing you need to keep in mind is whenever you're working on these fryers, okay, if you have a schematic for an electric fryer, the ones prior to May of 2006, starting from January of 97 to May of 2006, the fryers electrically are very similar. As a matter of fact, they're identical, okay, except for the plugs were changed. The reason why that's important to realize is the numbering of these pins was changed at the same time. Taking that plug from the back, you turned it upside down to put it on the front. So whereas this here is now pin number 1. Okay, so it's 1, 2, 3, 4, 5, 6. Before it was different. 6 and 9 are the 2 pins that you would check, okay, for the high limit and drain switch. And I'll show you that when we get to the wiring diagram. But we would check that. Looking at the schematic, if you had an older schematic, it's going to say 3 and 7, which would be, or 4 and 7, I'm sorry, which would be down here. Okay, the traces and everything on these boards are exactly the same. The only thing that changed is the numbering. So you just got to make sure you're using the right schematic. Whenever you're working on one of these fryers that has the plugs in the front, make sure your wiring diagram says RE. Okay, when we get to the end of this, the last thing we're going to go over is a wiring diagram, and you're going to see it. Otherwise, you're going to be checking the wrong pins. Okay, we do have some test lights up here, which the next slide I'm going to show you that. And also we'll go over these test points right here. Okay, this is the board. Okay, it looks a little different than the one that we've seen. As a matter of fact, we can go back, we got time. This board right here, if you notice, only has 2 relays on it. The reason why that board only has 2 relays and this one has 4 is because this is going to be for a fryer that can be used as a split pot. If you have a fryer, even if it was that one that I just showed you before that had the 2 relays, if you're working on that and you determine it's got a bad interface board and you order a board, this is the board you're going to get. Okay, that other board is only used in manufacturing. Okay, this, you know, we get this questioned on this quite a bit. Somebody gets a board and they say, hey, wait a minute, this isn't the same board that I got. You know, it looks different. It's got more relays on it. This is a service board. So whenever you order this board, this interface board can go full pot, split pot, or whatever. Okay, whereas the other one can only be used as a full pot. But in manufacturing, there's no reason for us to put these relays on if we're not going to use them. So it's just a cost-saving thing. All right, but this right here is a service board. This will work on any electric fryer prior to the touchscreen. Okay, the touchscreen fryers have totally different components on them. All right, But if you have a standard electric fryer, which had a manual filter system, that means you have to open the drain valve, you have to turn the pump motor on and open the return valve manually. If you have that, or if you have a Love fryer or a Filter Quick, the interface board is exactly the same. The heating portion of those fryers are the same. Touchscreens are a little bit different because the touchscreen and the interface board that it has, the roles change a little bit. Okay, but on the standard ones like this right here, this board is just there to do all the work that the controller tells it to do. This right here, there is no software, there's no memory, there's nothing like that on this board. Okay, this one here is just to do the work that the controller tells it to do. And we'll talk about how that communicates. We talked about that in the class we had yesterday. We'll hit on it just a little bit today also. All right, but this is the interface board. These lights at the top that you see up here, they changed a little bit. They used to be red, but when we started manufacturing our boards a little bit different, it had different LEDs. This right here, the CMP light, that's for computer. Our computers on our fryers, okay, we had some pasta cookers that were a little different, but on our fryers always work on 12 volts AC, which internally it creates DC, but the input voltage is going to be 12 volts AC. This light here indicates that we have voltage coming on our interface board for the 12 volt circuit, okay? I've mentioned every course that we've had this week. These lights are a handy tool, okay? LED lights or indicator lights, whatever you want to call them, no matter what you're working on, they are a very handy tool. They cannot be used to condemn a part, though, all right? Not them alone. You can check and you can say, okay, yeah, we have some voltage coming on that circuit, but it does not tell you how much. That's like those people that come out to work on something, they have those little lights where you ground one end and then you just probe things with the other and say, oh yeah, I got voltage there. It doesn't tell you how much. Okay, it does tell you have voltage, but not how much. These lights are the same as that. Okay, technicians don't use those indicator lights. We use meters. All right, if this light here comes on, okay, that means, or this one, if it comes on, that means you have 2 volts coming to that board. Okay, guaranteed we have, or 1 or 2, whatever LED takes. I've heard both, but the thing of it is, it doesn't tell you have 24 volts. All right, a meter will tell you how many volts you have. All right, but again, they're a good indicator. The HT light is the light that comes on whenever the heat relay that's on the interface board closes. The HI light will come on when the latch relay closes. The latch relay is a double throw. So you're either going to have voltage going to the latch contactor, okay, or you're going to have voltage going out off the interface board back to the computer for the computer to say help, ignition failure, or heat failure. Okay, if the latch relay is not closed when the fryer is on, okay, that means that there's a problem. I'll show you that when we get to the wiring diagram, but usually that means either our high limit or our drain switch is open, okay, on fryers that are equipped with a drain switch. That's why it says HI, that stands for high limit, because that's in series with the high limit, okay? This light or this light will always be on, one or the other. So if this light is off, this light will be on, okay, as long as the fryer's got power to it. This one here is just going to come on whenever it calls for heat. All right, that's what the lights mean. This right here, I'm going to go ahead and wait till we get to the wiring diagram. All this information and all these pictures and stuff are all on our tech reference manual, which you can get online. You can download it online. It's on there in the in completion. That's the book that we use in all our classes. Okay, so whenever we're going through these slides, as a matter of fact, that's what all these numbers are down here. This is the page number in that this information is on in the book. All right, so if you guys want to, after this, go ahead and download that. If you're taking any notes, you can put it in there. But all of this information is in that book. It's a very handy book. That we try to keep it small and just very factual. Okay, so that way it doesn't get too big. You know, we want you to have as much information as possible in a small book, but they are very handy. That's the book that I hand out in every class that I have. That's kind of our textbook. But all this information is in there. I'm not going to read through every one of these because all of this information is on the wiring diagram also. Some people like it in this chart form like this, so we always leave it in the book. But, you know, we're technicians. I mean, we can read wiring diagrams. All this information will be on there. All right. The next thing we're going to discuss here is contactors. Very simple. It's it's a relay. You got a coil which is 24 volts AC. When we put voltage to that coil, it becomes a magnet, pulls those contacts down. We got pieces of metal that touch each other that complete our circuit. All right. The latch contactor never switches any current if the fryer is operating properly. If a latch contactor is switching current, that means we have an issue. Either we got a shorted element or we got a stuck heat contactor. But these right here, when they pull in, there should never be any arcing or anything like that because they're not switching any current. All right, we've used these contactors as long as I've been here, which has been about 20 years, and they used them long before then for a latch contactor. Again, they should never go bad. And a lot of companies have this as a rule. If you're changing out a heat contactor because it's stuck closed, which is worst case scenario, but if you had an issue where we either had a shorted element or a stuck heat contactor, a runaway fryer, that means that these were switching the current, which they weren't designed to do. A lot of times, if you're switching a heat contactor, companies want their policies is change the latch contactor too. I don't disagree with that. All right, because that's a lot of wear on these that they wouldn't normally have. Normally, these things will last forever. Okay, it's kind of hard to tell if you got an issue with these sticking because they're pulled in all the time. Unless you actually go down there and check it with a meter, you're not going to know if it's stuck because once you turn the fryer on, these pull in all the time. The only time that this would be an issue if they stick is if either your high limit tripped, okay, or you open the drain switch. The fryer would continue to heat if these stuck closed. But again, these contactors get very little wear, okay? They don't cycle on and off very much at all, just normally once a day, all right? So those are the latch contactors. That hasn't changed in forever, all right? Heat contactors is a different story. May of 2008, actually it was April of 2008, it was decided at that point we were at a big show for one of our major customers, and we had some issues with the Duracool Mercury contactors. Well, we didn't, Duracool did, and they were sticking. And at that point, it was like, okay, we've been on the fence anyway with these Mercury contactors. We don't want to have them in our stores. Mercury's become a substance that people just didn't want to have around food. So it was decided at that point to go ahead and get rid of the Mercury contactors. The option that we chose at the time, all right, and some of you guys, usually in the class now, it's like, why don't you use solid state relays? Why don't you use this or whatever? Solid state relays we actually have used in fryers before, and they haven't. Yeah, the lifespan of those doesn't meet what a Mercury contactor was. It's really not much better than what the mechanical contactors were. All right. Plus, they take up a lot more room because they produce so much heat. You got to have big heat sinks. The cost of them are very high. So it was decided with all our customers and UL and everybody else that we were going to go with the mechanical contactor. We just took the contactor we had, got a little bit bigger one, so a little bit more robust. And again, they worked, but they didn't get the lifespan. They got the lifespan that we were told they were going to have. And even though everybody agreed with it, at the end of the day, when the bills started coming in and having to change these, it was like, okay, that's not going to work. All right. So what they did then is we went out and sourced this one, and this one does seem to be working well. There's a couple of things though. We did more than just change the contactor at that time. On the fryers that we had going out, we also did a software change. When the class that we talked about yesterday, or some of the stuff that we talked about yesterday, was on the controllers. They can do different things, okay? One of the things that they can do more things than what a mechanical thermostat can do. One of the things they can do is whenever we get close to set temp, okay, they can start pulsing on and off so we don't overshoot the temperature. One of the other things that our fryers do, whenever it's sitting idle, okay, it's programmed into the computer to come on and go off in short durations, okay, to maintain temperature. The cycling that we had going on would always pull these contactors in. So even if you were sitting in a room, and we've done it because, if you're, demoing a fryer or whatever, when you're sitting there, the fryers, once we had mechanical contactors, if you had a 4-bank fryer, you had a symphony going on of clunking because it would It would cycle on and then off. Then the other one would cycle on and off, and it would just be a continual clunking noise going on. All right. What we did is we minimized how many clunks we have in that time span. So we cut it by a factor of 3, I believe. I mean, whatever the numbers were, but we cut it down. So if you had a 24-hour store, I mean, just imagine how many times that heat contactor would cycle. Okay, just sitting there idle, even if it was a slow time and you weren't using the fryer. What we did is we cut that way back. So all that was done at the same time. So, whether this was the real savior, which this one does seem to be more robust, or if it was the fact that, we cut back on how many times they cycle, that together, the lifespan of our contactors has greatly improved. Okay. But I would have to say, considering these contactors are going in fryers that didn't necessarily have the software upgrade, then this contactor here is probably just working out to be better. All right. But in a combination with new equipment that went out, they had the less cycling and the new contactors. Yeah, our issues with contactors is pretty much gone away. So, but this is the contactor here that you would want to use. This is the part number of a kit. Okay. If you have a fryer that was built after June of 2017, it came with these contactors. So if you just got the contactor, it'd be a plug and play. All right. If you had these contactors, or you're working on a fryer before April of 2008 that had the Mercury contactors, this kit you could use to replace that. You're going to get the plate that comes with it and all the stuff that you need to replace it, instructions or whatever, okay, will come with this kit. I would recommend, even though it's probably got a little extra expense to it, but just, one size fits all type deal, I would recommend stocking this kit here. Over the last couple of days, we've discussed, several things like this, okay, with the changing of parts. We usually have a kit that makes one size fits all. Okay, we mentioned it with the ignition modules on Tuesday, and now with this contactor here. All right. This here is the Mercury contactors we used to use. I didn't realize that picture was that bad, but the we stopped using those back in April of 2008. Can you still get those? Yeah, if you order them from us, in our distributor that we use, you can still get these contactors. If you have a fryer that has a Mercury contactor and you want to replace it with a Mercury contactor, you can do that. They're not outlawed or anything, but it's just that our customers chose not to use them anymore, so we don't. Okay, but if you have a fryer that has one in there, you're more than welcome to use those, and you can get them from us. With that said, you may be working on equipment, okay, of ours that has Mercury contactors in it. In the time that I've been at Frymaster, probably 4 or 5 different occasions, Mercury contactors that were broken open became a real issue. Okay, we had some worse than others. We had one that generated a $10,000 bill. Make sure that you have a procedure, okay, in place to deal with a Mercury contactor that may have broken open and has Mercury free in that box. There are kits that you can get from Grainger. If you notice, these say recovery kit. It is not a spill kit, okay? I came from a different industry that dealt with hazardous waste, radioactive material. Spill means something totally different in the world of hazardous material. That means you've lost, control of a certain amount of whatever it is, okay, that exceeds the limit that's allowable, all right? You're not going to do that with this contactor. Even if all the mercury in here got released, that you're not going to need to do all those requirements and stuff. You saying that, is that going to be enough to satisfy a customer? Probably not. Maybe not. All they see is mercury in a restaurant where they serve food, okay? And I get it. I understand that, people would have real concerns over that. These kits, though, come with a lot of with all the information and stuff that you need to address all the questions. I don't know how much the kits cost. I know at one time Grainger had them, which I still believe they probably do. This one here I actually got from a company called Mercury Displacement Industries. That's what MDI is. It's a company out of Michigan. They were very helpful. We used to buy contactors from them. It was our backup source. This one here is actually a Duracool. But they sent me this kit, and they helped us in the one situation I was dealing with. But anyway, have a kit and just have good answers. If somebody sees that you're working on a fryer, oven, whatever it is, there's still some people that still use Mercury contactors is just if you get in that situation, if you have good answers, I can tell you it's going to, help with the situation. Because I've seen some that elevated out of control and it resulted in a lot of money. I've seen a school evacuated. So, yeah, we just want to make sure that we have good answers on that. Our equipment now doesn't have them. I took this out of the presentation, but you know what? It's just a helpful hint. There's other stuff out there that you're working on. Let's just avoid the problem. So, but anyway, just make sure that you have good answers if you run into a situation like that. All right, high limit. All fryers are required to have a high limit. Okay, it's a law. Never, never, never override a high limit. Okay, if technicians, if you want to do it for testing, that's fine. I have whenever I was in charge of the call center years ago, I had a rule. If a person does not know how to change the high limit or have a high limit in their hand, okay, ready to change it, well, even they might have to order it. There's never a reason why you would want to tell somebody how to override a high limit unless they're a technician and can change it. For troubleshooting, that's fine. But if you tell somebody on a Friday, okay, well, if you did this just to check the high limit, all right, to see if it's bad, but we can't get out there until Monday, or we're not going to have the part till Monday. I can tell you human nature is that fryer is going to be working all weekend. All right, and come Monday, it's going to be forgotten. It's like, okay, why am I going to spend the money to get it fixed? It's working, everything's okay. I'm not going to lie to you. There's appliances in my house right now that have stuff that's overrode, okay? But we do not want to be the last one to touch a fryer, okay, and leave that high limit jumpered out, and then something happened, okay? I mean, liability in this career field is very big. There's certain hazards and things out there like that. We don't want to put ourselves in that situation. All right. The high limit that we mostly use is going to be the same one that we use on all our fryers. Okay. It's the kit that we have that has all the different connectors and stuff. On the bigger KW fryers, which are pretty rare. Okay, normally you don't see too many 22 kW fryers unless it's like in an institution where you got 480 volts, because otherwise the amp draw is so big. Hospitals, prisons, schools, things like that cook a lot of food all at one time. They may have the bigger fryers. The high limit on those are different. Okay, just because they heat so fast, you got 10 degrees higher. It's a UL requirement. But anyway, most of the fryers that we have are all going to use the same high limit, which is, trips at 425 degrees. As a matter of fact, every fryer that is badged Frymaster is going to have that same part. So, but anyway, just make sure that we have a high limit that's in place and it's functional. It used to be whenever we did a startup, we always did a high limit check. That's not the case anymore, because if you went in there and did a high limit check and burned up the brand new oil, you're probably not going to be asked to come back to that store again. The only places that I know that do high limit checks is the military. We get calls from them quite a bit, about how to do high limit checks. But other than that, I don't know people to do it regularly. But anyway, yeah, just make sure that the high limit is intact and that it is working. So, all right, the elements. Again, these fryers here, one of the benefits that we have with these is the fact that our elements will lift up. Okay, at one time, that was a big deal because ours is the only one that has it. I see the other, brands of fryers out there now, all of them have elements that lift up. Obviously, the biggest advantage to that is when you lift these elements up, it makes cleaning these fry pots so easy. If anybody's ever had to work on it, and we make a fryer, an economy type fryer, that has elements that are fixed into the vat. Okay, trying to get underneath those elements to clean is pretty tough. Whenever we used to go to, different chains and things like that and show our products against other ones, the selling point on our electric fryer, and we normally always won, the business for electric fryers, is because we could lift the elements up. The drawback, like I said before, was the fact the old design where you just had a plate here, you left an opening to the back of the fryer. Okay, with this one right here, that's corrected that because these seals right here keeps that oil from migrating back. All right, this here obviously is a split pot fryer. For people that don't know what a split pot is, and there is some confusion out there, sometimes people think a two-bank fryer is actually a split pot. A split pot is a fryer that you take one fry pot and put a divider in there. Okay, so one controller is actually controlling two separate small pots. the biggest user of these is going to be, well, convenience stores do. We have some convenience store chains out there that like these, and McDonald's uses a lot of these. The reason for it is if you have a product that you don't cook much of, fillet of fish, that you want to keep segregated, these are perfect for that. Okay, these would not be good for French fries or things like that because of the size of the batches and stuff. But these are good for just smaller batch items and stuff like that if you want to keep the oil segregated. Some of the things that we want to look for, okay, on elements. I get asked a lot to go to different chains and stuff and do like preventive maintenance seminars. Sonic, if anybody out there works at Sonic, they do a very good job at that. They do anywhere between 4 and 6 of those a year, where they get their managers together and they get taught about preventive maintenance and stuff, and it makes a big difference. Okay, when they educate themselves and try to keep up with things. Gas fryers, there are high efficiency gas fryers, things like that. There's certain things, gas air mixers, clean the blower, that type of stuff. When it comes to electric fryers, there's not a whole lot to discuss. All right. I mean, electric fryer is a switch that controls a switch that controls a switch. And I'll tell you what I'm talking about there when we get to the wiring diagram. There's just not much there. You flip a switch, it either happens or it doesn't. There's not balancing things. Amp draw, yeah, that's a great check you can do, but usually people at store level can't do that. The one thing I always tell them, though, and the one thing that I mention to technicians, look at the elements, okay? Just take a look, just a visual inspection, and just see if you see anything obvious. Now, I do have some here that's got some issues. This one here is obviously brand new, but I'll show you some pictures of some issues that you may find. But the things that you want to look for, the new oil that is being used now, okay, it sticks to everything. It just clings to anything hot, all right? This element gets very hot. So, but the element, the heating portion of this element doesn't start until about right here. And you can actually see a line, well, I mean, imaginary line, where from here all the way around, now it just becomes carboned up. It looks like somebody powder coated it in a flat black finish, all right? And it usually starts about here. If this area where that black is starting to rise up to where it gets up in here, that's an issue, all right? It shouldn't start heating up in here. This here should pretty much stay clean. It's not until down around here where you're going to start to see that black. If you see carbon build up, and you will, okay, it's a lot more now than it used to be. That new oil is totally different. When I say new oil, I'm talking about that zero trans fat oil, totally different. But if you see all this carbon, and it's a nice finish. It's a nice flat black, looks like powder coat. But if you see a spot, okay, that is clean, all right, that's an issue. Because what happens is that carbon's burning off. And if the carbon's burning off in one spot but not the rest of it, that means we got a hot spot there. And the other thing that you may see whenever that happens is it may be a nice, real pretty cobalt blue color. That just means it's getting real hot in that spot. What that's doing is eating away at the insulation, which I don't know what that material is made of. It's a fibrous plaster-looking stuff. I don't want to use the word asbestos, but coming from the shipyards, I mean, it looks like that's what it looks like. But that's what's inside there. And there's 3 filaments, whatever you want to call them, that go around in here, okay? And but you'll see all of that. It goes through there. So you want to make sure that that insulation is not breaking down. But that's the stuff that you want to look for on these elements. All right, you may see things start to swell, and I got some pictures of that here a little bit later. But those 3 film, or the actual 3 separate elements in here, okay, and then they're surrounded by that insulation. If they start to break down, it's going to start to show you signs. If you run across one like that, it's going to be hard to tell somebody. It's like, hey, I think you need to spend $1,000 to change that element out, okay, or you may have problems. Now, they're not going to, it's working, everything's good. I would, though, definitely document it on your work order, okay? Have them sign it, say, hey, I let them know, because if you leave and a week later we have a failure on that, all right, you want to make sure that you have something in writing saying that, hey, I let them know that. All right, inside the element, those elements that I was talking about that are in the inside, all of these is just a resistor. Any heating element is just a resistor. Okay, we put voltage to it. It goes through that resistance. That voltage drops. That energy doesn't disappear. It turns into another form of energy, which in this case is heat. Okay, and that's what we're trying to do. All right. depending on the voltage, okay, and the kW rating is going to depend on the size of the resistor, okay, that's used, or the resistance that's used. All right, and we can check those by ohming between 1 and 6, and there's going to be 6 wires on here. The loops are 1 and 6, 2 and 5, and 3 and 4. And we want to check each one of those before we install that element, make sure they fall within this range. If you have the wrong size element, and it is stamped on the element, okay, the voltage and the kW rating, it is stamped on the element, but it's good to go ahead and check it again. If you have one that's open, there's no sense in installing that element. I mean, it's bad. If you check the resistance on here, and if it falls in place, though, that means that it's going to be that voltage and the kW rating that you need. On the voltages, you got to make sure, okay, that you're installing the right voltage on a fryer. If, for whatever reason, you install a 8.5 kW element, okay, in a 14 kW fryer, that's not the end of the world, okay? As long as the service in the store can handle it, okay, that's fine. The only difference between a 14 kW fryer and a 17 kW fryer is the elements. That's it, all right? As long as the service, okay, in the store can handle it, I mean, that's fine. It's not going to hurt anything. You cannot, though, use a 208 element in a 240 store. And every now and then it happens. 208 is the most common. Every now and then somebody runs across a 240 store and a 208 fryer goes in, and it's not going to last. It will not work. All right. So just keep that in mind. All right. This right here, this chart just shows you the amp draw on each fryer. If you got a 208 fryer that's 14 kW, which is our most common, 39 amps. Okay. And then so on and so on. Some of these are overseas units and things like that. That's the amp draw. I can tell you after January of 1997, trying to get a 3-phase amp draw on our fryers is pretty tough, okay, because the terminal block where the wires come in is inside that contactor box, and it's pretty hard to get to, okay? But you can do it. I mean, I've worked with electricians before that were retrofitting stores for electric. I mean, you can do it at the, you know, the breaker box. I'm not suggesting you have to do that. If you can't get a 3-phase amp draw actually on the terminal block, you can just do an amp draw on each one of the wires, okay, and just make sure when it's calling for heat, each one's got an amp draw. Like on this fryer here, you would have about 11 amps per wire, okay? I just know that because I've done enough of them. But, and then when it stops calling for heat, make sure everything goes back to 0. That's satisfactory as far as doing an amp draw during a startup or troubleshooting or anything like that. All right, we want to make sure that every wire has amperage on it when it's calling for heat, and every wire is at 0 when it's not calling for heat, okay? But this right here is the chart if you are able to get a 3-phase amp draw. This slide here, actually I jumped ahead a little bit because this is the same one that we had before. I was going to mention, you know, all the other stuff internally. This is where I was going to start talking about the inspections. So I jumped ahead a little bit. But like I said, the things you're looking for, swelling, okay, swelling of the elements. We want to make sure that if we got carbon built up, that it's pretty uniform, okay? Because if it's not, that just means some spots are hotter than others. That's because it's burning that carbon off. There used to be a procedure that some chains had where you lifted the elements up and you burned the carbon off, okay? But we don't do that anymore. All right, so anyway, that's what we need to do here. All right, temperature probe is mounted onto the element. That probe is on there because if you lift that element up, okay, and we forget to shut the fryer off, that probe is going to pick up an increase in temperature. And we talked about this in yesterday's class. It's going to pick up a fast increase in temperature, and it'll make the fryer stop heating. Okay, so we need to make sure that this probe is properly mounted on there, okay, because if it's dangling down below, that safety feature is going to be gone. Another thing, let your customers know, okay, if they're doing a boil out or if they put new oil in this fryer, when it's heating up, okay, make sure that they don't see little streams of bubbles coming up. Okay, that there means that we got a hole in that element. All right, they call those smokers because, you know, when it gets to the top, then you get a little puff of smoke because it burns the oil up along the way. Normally they're going to notice an issue because they're going to burn the oil up. It's going to be tasting real bad very quickly. All right, but something like that, that element needs to be changed. I mean, that one's past due. Okay, but again, swelling, discoloration, if this line in the back, all that changes, those are signs that we got issues with those elements. That one where you see the bubbles coming up, I mean, it needs to be changed. Okay, that's just not something that may happen. It's going to happen. That insulation has been compromised inside the cladding here. All right. Here's some of the things that we were talking about where those clips on that holds the support bars. You can see where it's swelled up. That starts to cut into the metal. This is usually where you start to see a break, things like that. This, worst case scenario. This is what you're trying to avoid right here. All right. I, for years, have been trying to get a picture of one of these things. And I was in a class last year, and a guy had just changed out this fry pot. And he took a picture of it and sent it to me. If you guys have pictures of stuff like this that would be good in training, please send it. You got my email address? Please send it, because this stuff is really good. But those ties that hold that temperature probe on, which I don't know why, well, I guess one just slid down. But anyway, the swelling on there, it broke through, and that voltage is inside there on those elements, is looking for a ground. Guess what? It found it right there. So now, and there was probably signs on here, although it's not looking too swelled up. But the thing of it is now instead of just changing an element, you got the whole fry pot that needs to be changed. Who knows what happens with all that oil pouring out of here down into the boxes and stuff. But this is absolutely worst case scenario right there. All right. Now we're up to the wiring diagram. Okay, we're just going to go through a few things. I talked about this yesterday, so I'm not going to go in great detail because, you know, for our segments, I have to split things up. So we talked about how this works, okay? And we talked about how the fryer calls for heat. This resistance gets compared to this resistance. Whenever this resistance is lower, it's going to call for heat, meaning, well, when we turn the fryer on, we have 12 volts DC because it goes through a rectifier, 12 volts DC that comes up here to the latch relay. That relay is going to pull in. On our electric fryers, as soon as you turn the fryer on, the contactor pulls in because this relay pulls in. It's already grounded. The heat relay, okay, is looking for that ground that it's only going to get whenever this resistance is lower than this resistance. Then it knows in order to get this resistance higher, we need heat. It gives the ground to this relay. That heat relay then is going to pull in and send voltage over to our heat contactor. That's when we're going to hear the other clunk. Soon as this equals this and it shuts off, then it's going to release. As soon as it drops down, or if it's sitting there idle, just on a timed fashion, it's going to cycle on and off. All right. We drop product in there. We push the button, then drop product in there. That's the procedure we're supposed to do. Because when we press the button on the controller, it automatically pulls this in, anticipating the fact that we're going to drop temperature because we're about to put product in there. So we push the button, this contactor pulls in, all right, then we're going to start heating. This contactor stays pulled in as soon as you turn the fryer on. When we get voltage to the coil of the latch relay, the 24 volts AC comes in, goes through the relay on the interface board. It goes out pin number 6, goes through the drain switch, goes through the high limit, comes back on pin number 9. So if you need to troubleshoot that high limit and drain switch, all you got to do is ohm those 2 pins out. That's why I pointed those out on the test point, because that's a pretty common test that you got to do if you're checking those two. Comes back pin 9, comes over here to the latch contactor, and it pulls in, stays pulled in as long as the fryer is turned on. All right. This one here is the one that's going to cycle on and off. All right. When you turn the fryer on and it's not calling for heat, one of the checks that we need to do, and I'd mentioned it earlier, do an amp draw on all these element wires. And you can do it on the 3-phase, but the element wires are a lot easier to get to. You can do that from the front. But do the just put your amp meter on there and see if you got any amp draw. If you do, okay, either we have a contactor that's stuck, or we have an issue, okay, where we got a short in one of these wires. It's not that uncommon. It's more uncommon now than it used to be, but for whatever reason, and maybe it's because I was working on electric fryers so much when we were doing a retro kit years ago. But yeah, if you like take the panels off the back and get one of these white wires that come off the elements pinched, okay, we just provided a ground. We got voltage, we got a load, we got a ground. That's a circuit. okay, it's going to start to heat. That one pinched wire could cause this fryer to heat to the point it'll trip the hot limit. The elements are in the oil. All the heat that's produced goes in the oil. None of it is lost. They're 100% efficient because none of the heat is lost. It all goes in the oil. So even just having one of these heating, okay, could cause that thing to trip a high limit. One last thing. Typically, for our controls, we tap off at L1 and L3, and that's what feeds our transformers. They're either 208/240 or whatever. In a McDonald's, all McDonald's has 120 volts coming to the fryer tied into the hood system. So since 120 volt transformers are cheaper, we're going to go ahead and use that 120 that we already got coming in there, and we're going to have 120 volt transformers. Our filter motor is going to be 120 volts. All of that's going to operate from that incoming 120. But if you notice, okay, these elements obviously are going to be tied to the three-phase power. So we can have all of this come on, and we can hear all that clunking going on with these contactors cycling on and off. That's all coming from the 120, and yet we can have a three-phase power cord unplugged. That fryer will never heat, okay? That is very common, okay? The reason for it is because in those stores, these three-phase power cords are not locking. And if you pull a filter pan out, you hit one of the cords and that plug comes, it becomes unplugged, okay? This thing will sit there and cycle on and off all day long, like it's getting something done, and you will not heat at all right? Anytime somebody says, in a McDonald's, because they have the 120, they're the only ones that have that. It could happen with anybody, but they're the only ones that are using it. If you have a fryer that's cycling on and off, but it has not heated all day long, and now you're going into lunch and it still has not heated, make sure that they check to see that it's plugged in, insist on it, and or if it is plugged in, make sure a breaker didn't trip. Okay, we've seen both. If somebody comes in and works on the hood system, they clean at night, pull the fryer out, you push the fryer back in, and you're trying to get all those cords in behind the fryer because there's no room. All right, sometimes they come unplugged. If somebody's working at night, they're not going to heat that fryer up to make sure everything's working. They're not going to discover it until the next day. That happens. There's not a week that goes by that we don't deal with that. Okay, it's just one of those things. So with that, I think I'm just a couple minutes. No, right at 11 o'clock. So.